fifth question. A book of mass 3 kg. This is the book. Okay, is prevented from sliding down a slope of at 15 degrees. So this is basically the book is resting on an inclined plane, which is inclined at an angle of 15 degrees. Okay. Find the force of friction and normal contact force. Now, a good mechanics student must be able to show the forces which are acting on the given whatever particle block, or like we have the book in this case. Okay, so the first thing over here is the weight. Okay, the weight that has to be shown exactly vertically downwards. This is the weight. Okay, this is 30 Newton. Remember, W is equal to mg. Okay. Now, so this is 3 times G. G is taken as 10. So weight is 30 newtons. Okay. Now, what is basically if you drop this, like, you know, freely under gravity, this will go down because of this weight 30 Newton. Okay. Accelerating with this G. Now, this is like, you know, resting on this inclined plane. So you have to know that what is the component of that weight which is parallel to this direction over here. Okay, so I'll be resolving this weight parallel and perpendicular to this surface on which this book can move. Okay, so I'll be drawing a line like this, and you see this weight. If this is 15 degrees, this is going to be 15 degrees. I have explained this in the previous video. Okay, so this one is going to be 30 cos 15, and this one is 30 sin 15, and here is that R. Okay, this is the R. Since you can see that this component of weight will try this book to slide down, and since this surface is not smooth, there is a friction, so the frictional force will be acting in this direction. Let me name this as F. Okay, so now this book is prevented from sloping down the plane. So we have to see that what are the forces parallel to this inclined plane. So this weight, this component of weight wants the book to go down this inclined plane, but this is prevented by this upward frictional force. The frictional force, remember, it is always opposite to the direction of the motion. So the book wants to go down, okay, but this friction will not allow. This is right now, it is not allowing it to go down. It is preventing this to slip down. So that means this is in a state of equilibrium. So this frictional component over here is going to be, F is going to be 30 sine 15, and your R, this upward and this downward perpendicular to this inclined surface, this R is going to be 30 cos 15. Okay guys, the 7th question. Now the 7th question says a particle of mass 2 kg is held in equilibrium on a slope at 13 degrees to the horizontal. 13 degrees, you can see this, 13 degrees to the horizontal by a force F acting at 10 degrees to the slope above it. Find F and the normal contact force. Now here he must have told us that the surface, this inclined surface is basically a smooth surface, because he hasn't asked about this frictional component. So we are assuming that this is a smooth surface. Okay, so guys, first of all you have to show the weight. Okay, this weight is vertically downwards. This is exactly this is a bit like this is the weight, which is 20 newtons. Okay, remember, you keep your pencil or pen here and you draw a line like this perpendicular to this inclined surface. Okay, so this would always become R, and if this is 13, then this is going to be 13 over here. Okay, there is a right angle. So this component is 20 sine 13, and this one is 20 cos 13. Okay, now this force F, this is neither parallel nor perpendicular to this inclined surface. So you have to resolve this parallel and perpendicular to this inclined surface. This is going to be F cos 10, and this is going to be f sine 10. Okay. So now we know that this block is in equilibrium. So first of all, I should be allowed to write that this weight is being balanced by this upward force. So this f cos 10, that is equal to 20 sine 13. You will get f from here. Okay, your f will be 20 sine 13 over cos 10. Okay. And then we will find this r. So you see, this is the first force, the second force, vertical, and this is the third vertical force. So we shall say that this r plus f sine 10, that is equal to 20 cos 13. Okay, you substitute this value of f from here to this, you will get your r. That is 20 cos 13 minus f sine 10. Okay. The 10th question from this exercise. A girl is dragging a sled of mass 20 kg up a slope at an angle 14 degrees. So this is that sled. Okay. So this is being pulled upwards with this force. Its weight is, its mass is 20 kg. So I'll be showing the weight like this, vertically downwards. This is the weight, which is going to be 200 newtons. Okay, and I should, whenever you show the weight, you must resolve this parallel and perpendicular to the surface on which this is going to be sliding. This is going to be 14 degrees. Right now there's a load shedding, so I'm sorry for the quality of light right now. Okay, this is your r, and this is 200 cos 14. This is 200 sine 14. By the way, today is the 27th March 2020. Okay, so we have resolved this weight. Okay, and now she is pulling this upward with a force 70 newtons, which is inclined, further inclined from this inclined surface at theta. So we need to resolve this as well. So when I resolve this, I get, this is 70 cos theta, and this one is 70 sine theta. Okay, and then it says she maintains a constant speed. So guys, remember, constant speed is just another kind of equilibrium. Okay, so that means the forces are all in equilibrium. There is no acceleration happening right now. So she maintains a constant speed despite friction of 10 Newton parallel to slope. So you see, you have to direct this 10 Newton downwards since she is pulling this upward with a constant speed. So the frictional force, it is always opposite to the direction of the motion. Okay, so now using all these components, now we have to find the the theta. Basically is he has asked to find theta and the normal contact force. Okay, so now looking at the components parallel to the surface, I have this 70 cos theta equal to 10 plus 200 sine 14. Okay, this 70 cos theta from here upward, and these are two downward. One is a frictional force, the other is a component of the weight. Okay, so this will give you the theta. So this is your cos theta, 10 plus 200 sine 14, and this is divided by 70. You will get your theta from here. Okay, and I will find your r. You have to look at the components perpendicular to this inclined surface. So this is this r plus there is 70 sine theta, and that is going to be 200 cos 14. Use this theta into this equation, you will get your r. Okay guys, this is the last question that I'll be doing in this video. So you can try all these questions from exercise 3b. Okay, so if you have any problems, do let me know in your comments or maybe in our WhatsApp group. Okay, thank you very much.